and welcome back to Azure Terraformer. Well, we just got done listening to Harold talk about the other Terraform announcements, new features like custom provider functions, Terraform test, and a few other things in Terraform Cloud. Now we're hitting pay dirt, everybody. We're talking Terraform Stacks. So get ready. Let's hear Harold talk about Terraform Stacks, and you'll get my full analysis on this pretty huge new capability built into Terraform. So without further ado, here's Harold.
So what happens is, when you start using Terraform, it's great. I write a little bit of code, I describe what I want the infrastructure to be, and I tell the system, make it so, right? And Terraform goes on and figures out what the dependencies and what the order of provisioning should be, figures out which APIs I should be calling to make that infrastructure happen, and it just feels magical. Then I go back to that same configuration and I change something, maybe an instance type, or I add something to the configuration, and bam, it goes and does it again. So that's a really important kind of innovation, I think. But what happens is, as you continue to add to that configuration, eventually you're going to start creating a hot mess, right? It just becomes really, really large. And when it becomes really large, a lot of issues start happening. For one, it's one of these situations where very few people in the whole organization can fit that whole thing in their head and say, I understand this code, I know how it works, and this is the change that needs to happen, right?
And really, it's not just understanding the code, it's understanding the architecture and the dependencies between all these things, right? If you don't have those boundaries, you don't have clear delineation of responsibility, it becomes, as he mentioned, a hot mess, right? So you really need to think through what those boundaries should be based on your organization, based on the responsibilities that you have allotted to the different parts of your organization, to make sure that the right people are in charge of the right parts of the architecture and the code that describes that architecture. So config sprawl is absolutely a thing. It really takes thought when you're doing a lot of people just think, oh yeah, infrastructure is code. You just jam that stuff into a text editor and you're done, right? Well, no, actually there's, a lot of thought that goes into the change management process and, how that aligns to your organization, who literally has the knowledge to maintain that code. The knowledge of the design, the knowledge of those systems that the code is managing. There's a lot of things that go in terms of deciding ownership and drawing those boundaries. And that often gets overlooked because there's one guy that knows how to write Terraform or knows how to do infrastructure as code. And it's just yeah, you're the DevOps guy, go do that. It's no, that's not how it should be. So, unfortunately, a lot of organizations are in that. I think we're getting into Terraform Stacks here, and one of the biggest things about Terraform Stacks that I'm really excited about is that Terraform Stacks kind of canonizes this concept of drawing those boundaries and taking responsibility for drawing those boundaries between those components of your architecture. So very excited about that. Not just from the bells and whistles we get in Terraform, but also how I think this is going to help people kind of wrap their heads around and apply some muscle memory to that process of setting up those boundaries.
It just becomes cognitively hard to kind of reason about, right? So that's problem number one. Problem number two is the blast radius is so large. I wanted to change, an instance type down here, but I also ended up deleting a database over there. I don't know what the relationship of that was, but oh my God, what do I do now, right?
So blast radius is often brought up, but I've never heard anybody mention really why. Blast radius is about risk. It's about managing risk and the various risk levels of different components of your architecture. So he mentioned the case, the common case, which is I want to make some changes to my web servers and I deleted a database, right? Well, what's the problem there, right? The problem is really you have different levels of impact when you make changes to parts of the system. If you've got stateless web servers, if they get deleted or popped in the head, right, it doesn't matter, right? It doesn't matter that much, right? But if you pop your database in the head, that's a massive impact, right? You got to pull backups and you got to go stand that up again, right? It's not just increment the node count, bring back some more web servers to handle that load, right? So blast radius, you really got to think about it from a risk management standpoint and tackling like what components of your architecture are very, very risky that you don't want to change very frequently, and compartmentalizing those into their own little space so that those areas that are low risk that you can change frequently or you do change frequently don't like cross paths, because then bad things can tend to happen like he just mentioned.
So that's that problem, all stemming from the fact that it's a very large module containing all this infrastructure. And there's tools for kind of going around that with targeted provisioning and things like that. The other problem is just performance. If you have a very large module like that, how do you provision that in a performant way? Really, you can't. You can't ask the system to go faster if you're asking it to kind of do all these, load all this into memory and just operate on that very large kind of code base.
And it's really not local resources that are the constraint. It's the physics about making all these calls outbound to the cloud platform that you're talking to, right? At the end of the day, you might get throttled by the AWS REST API. And each of these requests out to Azure or AWS, have a request and a response. And Terraform kind of has to wait for the data to come back before it can decide what to do next. So it's really not always about compute and memory. It's more about like the physics of like making all these communication lines outward to these remote systems. So
ultimately, we get to the point where it's like, I got to split this out. How do we do that, right? And so essentially what you end up doing is like taking chunks of that module, splitting it out into other workspaces. And now you're in a situation where I need to orchestrate these workspaces. How do I?
So he kind of glossed over this a little bit because that whole process of splitting it out is not easy, okay? He's kind of leapfrogging solving that problem because he wants to start talking about stacks. But let's be real. Like the breaking up a mega module into like sub deployments with well-defined boundaries and blast radius considerations, put in is not for the faint of heart. It is very difficult and very tedious, and very risky, right? So it's best if you can think through this stuff before you set all this stuff up and keep those blast radiuses small, so that it's much more easier to manage going forward. And once you've done all that, right, then stacks makes your life easier. That's the promise anyway.
Make sure that this one runs before that one. What if I'm sick or out or I'm PTO and nobody else knows how to run this thing? I need to write a bunch of documentation. I need to write wrappers around it to kind of orchestrate all this stuff. So it's a big mess, and everyone's solving this in a different way. Which is an issue, right? It's kind of a waste of cycles for the.
I agree. It's a week doesn't go by and I don't see this question show up on Reddit. Like how should I like organize my modules? Like how should I structure things? How should I split things apart? Right. And unfortunately, I have to respond to those with like some guiding principles, right? Because there's really no silver bullet for how to structure your root module or your submodules, right? For that matter. It depends on your architecture. It depends on, what you're trying to accomplish. And it depends. And so guiding principles are really what people have to work with. At least, with stacks, we're going to have some canonization of that process to apply those guiding principles and, kind of reinvigorate this process of going through that.
Right. Problem number 3 or 2, if you're counting from 0, is you have multiple environments. So I want to ship this same infrastructure into multiple regions, or I want to ship it into staging and production. And the only difference is these parameters are different. The console cluster should have 1 instead of 5 nodes, right? And staging versus prod, things like that. So really, there's like minor differences between the environments, but important ones, and really no easy way to model that in current Terraform, right? So all of these problems is what we're aiming to.
I mean, the way you do it today is you have, TFR's file for each environment, and that, has different inputs to your root module. And then you just stamp out that root module, for each of those environments. So there's some plumbing and some glue that you have to do, from your pipelines that provision it, which hopefully Terraform Stacks makes easier and more of a code-based exercise as opposed to kind of a Git flow process.
With Stacks, which is extremely excited about Stacks. And I'm getting ahead of myself. This is what it looks like currently in Terraform Cloud to work with that. So if I have to do this because I can't see that too clearly, but if you look at this, you have a console production US East workspace, right? And a console staging US West, and et cetera. And then we have an EKS production US East, et cetera. So you need to know that these are the same region, and you need to know that those over there are related, and that the Kubernetes cluster should be available before I provision console, as an example. All of this is like knowledge that a human needs to keep in their head to work with a system, right?
And this is a great picture of what my world looks like using Azure DevOps or GitHub Actions. I've got a pipeline. I've got a pipeline that provisions each layer of my architecture, and I've got a pipeline that provisions each environment of that component of my architecture, and then those pipelines have to kind of be stitched together so that I have dependencies flowing in from one to the other. So it's he's right. I mean, it's not for the faint of heart. It can be done. Hopefully, Terraform Stacks makes our lives easier. So
that is just not scalable, right? So let's work through what Stacks is and how it aims to solve these problems as in the next 10 minutes here. All right, so now we have one piece of config that describes all those pieces, right? So the stack actually contains information or knowledge about the relationship between these various modules, and also contains knowledge about the various environments in which it's going to be deployed, right? So to put that a little more concretely, here's another view of that. We have at the far bottom left components, and these rows here are the Kubernetes component. That's the Kubernetes module that we already know and love. Nothing changes around that. Then we have a HashiCorp Vault component and a HashiCorp Console component. This is just an example, right? But then on the bottom right, we have information about both the staging prod kind of relationship as well as the different regions.
So basically, the components and the deployments are new language constructs that we have within Terraform that describe another layer of our architecture, right? Of our deployment architecture. So we have Terraform workspaces today where we run a Terraform apply. Those are being encapsulated into a component, right? We have each template that we have for our layer of our architecture is going to translate to a component. Each time we provision that component to a new place, dev, test, prod, east, west, north, central, that will be a deployment of that set of components, right? And so today the component is kind of like what we have today which is our Terraform code, and then the deployment is kind of like what we have today, which is our Terraform state file, right? The state file is tied to the specific deployment of your Terraform environment, whereas your Terraform code describes what one of those environments should look like, right? And it provides input parameters to allow you to kind of alter those environments, between different application life cycles or between different regions, so on and so forth. So these components are going to describe that generic version of the thing, and the deployment is going to be that specific instance of that deployed wherever it's deployed.
Just deployment targets that we're defining for deployment of that stack, right? In this example, we're essentially trying to deploy a console cluster with certificates stored in Vault on a Kubernetes cluster. That's what we're trying to do. So you can see how already there's like various dependencies here. Kubernetes needs to exist before we put console on it. But Vault needs to exist before I provision console because I need the certificates there as well, right? So all that is the dependency management bits that we're going to start looking at how to solve with stacks, okay? So starting off with components, again, Kubernetes, Vault, and console. You kind of notice that on the bottom there, HashiCorp console, one of them is like taller or smaller than the others. And this is just saying like in that environment, there's more. But let's look at how what this code looks like, okay? So first of all, we're introducing a tfstack file.
So we have a new file type, tfstack, and there's a new top level verb or noun. I think it's better called a noun, called component. We got resource, we got data source, we have module, now we have component, right? And, when I first looked at this, I was like, why don't we just do this with a module? This looks exactly like a module. Like, why don't we just call it a module? But there must be something happening at a higher level than a Terraform apply where this component is being picked up and treated differently than a module would, right? And my initial reaction was like, I feel like we could do this all just in a Terraform apply. Like, we don't need this extra layer. But that would, I talked to Chris Arcand about this, in great detail at the booth and later, online. And, that would break the fundamental contract of Terraform, which is a Terraform plan is deterministic, right? And so if we were to solve this problem, like inside the Terraform apply and just, figure it out using cross-provider dependencies and things like that, we would basically have the situation where within the apply, we would have to poke until we got all the way through, right? And that kind of breaks that contract with the operator of like, this is everything that we're going to do. We're not going to do anything else. Are you cool with this, right? And so by introducing stacks, it allows the Terraform apply to remain deterministic, which means we know everything that's going to happen within that plan, and we can have much more predictability about what gets applied to our environment. Then at the higher level, when we have these dependencies across those components, right, then that's where we can account for the fog of war or the kind of unknowns of like, okay, there's something that isn't there yet that needs to be set up in this lower layer of our architecture before the higher layer of our architecture can be applied and changes made there. So I actually like this now. I was initially like, this seems like overcomplicated for what it's trying to do, but I think it is important to maintain that determinism within the Terraform apply and within that Terraform plan. Otherwise, everything is like going to be, less predictable, right? So at least within the areas that we can have predictability, we have it.
And essentially, we're bringing the component layer into the configuration. So here we have a component, an EKS component, and we're just saying, here's some inputs, and here's the providers that I need, all the module stuff that you know about already, right? And then on the right, we have a Vault component. Of course, same thing with a console, but it doesn't fit on the side. But really what I want to highlight is that line there. It's a lot of magic hidden in that one line. The one that says cluster name, component.eks, the cluster name. So this is us wiring declaratively, here's a cluster, here's the source of that. The input into this is the output of my other component. So that's how we're declaring and telling Terraform, you're going to build a graph of graphs, and here's how you're going to wire this up. And Terraform is going to figure that out, right?
It's kind of diverges. Like I just noticed this now. The syntax kind of diverges a little bit from a module, in that module input variables are not like grouped into an inputs collection. You can specify like provider aliases on top of modules, but I don't think they're attached using a provider's collection either. Or I guess that would be a map, right? So kind of wondering if this kind of syntax change is going to trickle down, to modules at the very least. Maybe probably not resources, dear God. But yeah, it's kind of interesting that they've gone with a slightly different syntactical model for the HCL for component. Could be a little bit disorienting, like going and looking at a bunch of modules and then going looking at components and seeing, on modules and resources and data sources, very flat inputs. But then over in components, we got this like grab bag of inputs, right? I don't know. It's just kind of weird.
So that is, I think, the key piece is that you don't need to keep all that sequencing in your mind. You don't need to script that out inefficiently. You can let Terraform do what it does best, which is resolve these dependencies and hit APIs and do it all for you, right? So next up, deployments. Deployments could be environments such as development, staging, and production. It could be multiple regions, points of presence. It could be different AWS accounts where you're going to deploy the same thing, kind of stamp it out. It could be landing zones or tenants, right, where deploy this app for each dev team, for example.
Basically, the way we organize our TF state files today, right? Like if you're going to have a different instance of your Terraform solution deployed to different places, right? I've implemented multi-tenancy, with this way, like where you have a root module for your tenant, and then every time you have a new tenant, you stamp out a new instance of that root module for that particular tenant. This is great when you've got tenant environments that need to have like physical infrastructure just for them, right? Whether it's a database or a virtual a VPN connection or something like that, to allow them to connect to your stuff. It can happen, right? So there are other scenarios where we need to stamp out deployments that are not always related to application maturity level.
Those use cases very well supported by Stacks. And then similarly, we have a TF deploy file. And look at all the stuff I'm not thinking about.
So again, we have new language structure here called deployment, which is very interesting. Again, this is taking it out of like the glue and the pipelines, where we would define our deployments typically, and putting it into a configuration. And now that I look at this across the board, with earlier we saw state-based operations moving into config. We see components and deployments and these higher order operations like falling into config. It seems like everything, like all of these components that are outside of the Terraform ecosphere today, that are like stitched together using GitHub Actions or Azure DevOps, are kind of moving into the config space, which seems to align with HashiCorp's strategy of creating Terraform Cloud, which is kind of abstracting the CLI. So it'll be interesting to see how this manifests as a CLI command. We have TF deploy and TF component, or TF stack and TF deploy files. So, there is a foreseeable path for us to run a Terraform stack or Terraform deploy command on a particular folder. So I don't think this is going to preclude the CLI. The CLI should be able to work with this, but a lot of work has to be done in the CLI to expose commands that are going to talk to these files. That identity token there is also, I talked to Chris about this, that is a hook into the Terraform Cloud's service connection thing, basically. So in Terraform Cloud, you set up connections to your AWS account, to your Azure subscription, and you can link to your code using these identity token blocks. So kind of interesting. I'm not sure why that needs to be in the code per se. Seems like that would be, kind of a meta configuration at the Terraform Cloud layer. I'll be curious to see how this identity token manifests itself in the CLI configuration as well. Because today we use environment variables and things like that to inform our provider configuration. Which, a lot of people are doing interesting things using OpenID Connect and kind of short-term, credentials to authenticate with AWS or Azure. But it's not super easy. So I'm kind of wondering if there's going to be more in the Terraform CLI that's going to make that easier.
And here is saying, here's a deployment, here's the name of that deployment, and here's the variables for that deployment. done. You add one of these blocks and you have defined a deployment, then now the system is going to know how to deploy to. So you're giving it all the inputs that it needs, right? So putting it all together, here's conceptually what a stack is. With components and deployments, you can easily spin up complex applications with tricky interdependencies between them as a single unit. So that's a lot of concepts.
So that's pretty much it. Next is a demo done by Chris where they provision this stack. You know, they got a Kubernetes cluster, they load Vault onto it, and they load Console onto it. And, you know, in Terraform Cloud, you know, not in the CLI, but in Terraform Cloud, you can kind of see Terraform Cloud run the plan and basically pick up, you know, the Kubernetes cluster, like I'm good to go. I have everything that I need, but for Vault and Console, like I don't have everything I need. So I need to kind of like run the first, you know, component and get that done. And then I'll reevaluate the plan. And now I'm poking further through, you know, maybe the Vault is cool, but Console's still dependent on Vault. So I got to wait for the Vault to apply. And then once that's done, like everything's good, right? So it makes sense. Like if you've built multi-layered infrastructure as code using Terraform, you've done this before. You've just had to put all the glue and plumbing yourself into it to make it work. So yeah, very, very excited to see Terraform Stacks. There is a sign up. So I'd encourage you to go sign up, get in line, and you know, go get your hands on it. You're going to need a Terraform Cloud organization to get started. So make sure you sign up for that. It is free. I have one myself. I just set one up. So I'm going to be kicking the tires on this once I get approval, and probably more content coming out from me on that shortly. So if you like this content, please smash that like button and consider subscribing to my channel. It really helps out a lot. I'm excited about Terraform Stacks. Are you excited about Terraform Stacks? Let me know in the comments below. And stay tuned for more here on Azure Terraformer. This is the Azure Terraformer signing off.